In this video, I'll teach you how to find the integrals, and we will talk about the rules of integrals. Exponentials, functions, and trigonometric functions, radical functions, those are all will have a rule. I'll give you one notation here. In derivatives, we have the rule for multiplication and division, but be careful, in the integrals we don't have the same rule that we did in derivatives. Multiplication and division, most of them you can't solve unless you will take it as rules. For any types they have rules, you will learn these later. But at now, how can we find a single function? Okay, not a chain rules. And not composite functions. Now let's start by the rule of integrals, but we will start the derivatives, then we will change to integrals. Let's start. In here we have the derivatives, and in the opposite side we have integrals. I know you took in derivatives, you know the rule of derivatives. Now let's start from derivatives and we will jump to integrals. Those are the exponential functions, a constant and exponential functions, and we have inverse function and radical function. Those are all can be solved by powers. Okay, how can we do each of them? F of x is equal to a constant number like 5, 15, minus 2, minus 8, any numbers which is constant, its derivative is equal to 0. And let me give you a note here. F of x is equal to 5. Do you know the graph of 5? It is on 1, 2, 3, 4, 5. On y-axis, horizontal. And what is the slope of this? Is 0, because it is a horizontal line. Okay, do you remember the slope? So derivative or slope, they are same. Now any number, its derivative is equal to 0. Now let's jump on integrals. What is integral over 0? Look, any number is equal to 0, so the antiderivative, it becomes 5, 7, 3, 8, any number, but which number we don't know. So any integral of 0, it becomes c always. What is c? C is like 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, 2 over 5, 5 over 2, 7 over 8, any fraction, decimal, or integers. So we can say it is all real numbers. C is all real numbers. F of x is equal to 5x is equal to 2. I know you have a question here. Why I didn't say it is equal to 5? Because I don't know what is the real function for this. Yes, we have the real function is 5 here. Okay, at now. But always when I give you, what is that integral of 0? It is 0. It is a constant number, but what's the constant number? We don't know. Okay. Here, f of x is equal to 5x plus 2. 5x, derivative of 5x is 5. And x will be gone because we have 1 here. 1 minus 1 is 0, x to the power of 0, and not need to write. Okay? And plus 2 is plus 0, of course. So that's it. What is, now let's jump on integrals. What is integral of 5? What's integral of 5? Integral of 5, it becomes 5 x to the power of 0. We have x to the power of 0. And plus 1, it becomes 1. So it becomes 5x over 1, and not need to write over 1. Okay? Here we have to write plus c. Why? Because maybe we have plus a constant number in the real function. Look, we have plus 2, so it is equal to 0, so we have to always write plus c. Next one, 3x to the power of 4. If you didn't understand this, it's okay. Let's go to this one and you'll understand this one also. What's the derivative of this? 3x to the power of 4. We can say it becomes 3 multiply this 4 comes to down, okay, x to the power of 4 minus 1, you can say like this, minus 1, so it becomes 3. Okay, so 3 multiplied 4 is 12, 12x to the power of 3, 12x to the power of 3. Now let's jump on integrals. We have 12x to the power of 3. How can we solve, how can we find the antiderivative or integrals? This is integral of 12x to the power of 3 dx. What's this dx? It means someone took the derivative and it becomes this. We have to find the antiderivative by using integrals. Okay? And this dx, it means du to x, derivative by x. Okay? So we will talk about this later, dx, dy, or any letter we have. Let's solve this. This is a constant number. If we have a constant number, write again 12. Okay? Like we had in derivative. X to the power of 3, write x to the power of 3 plus 1, and over 3 plus 1 is 4 over 4. So now this is equal to x to the power of 4. How about those two? 12 divided by 4 is 3. Look, we have same function as we had before. 3x to the power of 4, this minus 1 we did write because of the derivative, and 3x to the power of 4. But don't forget, plus c, always write plus c. Why? Because maybe we have a number after this. This is plus 0. Okay, maybe we have plus 2, so we have to always write plus c because this is called indefinite integrals. Let's go to the number 4. F of x is equal to 2 over x power 3. Okay, we have two ways, guys. Two ways. One of them, let me clean this and bring it here. Derivative of x is equal to, there are two ways, both of them is true. You can take x to the power of 3 to upward. You have to learn this. This is a very academic way. It becomes 2x to the power of 3, minus 3, sorry. Why? Because we took the x to the power of 3 to upward, to the numerator. And then is equal to, now let's take the derivative. Take this minus 3 to the coefficient, it becomes 2 multiply minus 3, it becomes minus 6, x to the power of minus 3 minus 1, it becomes minus 4. And then we have to take, don't write the powers with, or don't leave anything with the negative power, you have to fix the power. So take this to the denominator, and the minus of the power only will be gone, so x to the power of 4. Now let's use the second way, which is again equal to minus 6 over x to the power of 4. How? Let me write 2 over x to the power of 3 again, and wait a minute, x to the power of 3. Multiply this number to the upward, to the number in the up, but with negative. Minus 3 multiplied to minus 6. And we know that derivative, it means minus 1. Minus the power, subtract the power with negative 1. Okay? But here, because the power is in the denominator, just opposite of minus 1 is plus 1. So instead of reducing 3, increase 3 to 1 more power, it becomes 1 more degree, it becomes x to the power 4, and they are same. This way, if you use this way, and if you understand this way, it will be so easy. How about this one, guys? There are two ways again. For this one, we have an academic way, derivative, and I will talk about their integrals later. Derivative of this is equal to, we can say, square root of x, we can say, can we say it's equal to x to the power of, this is 1, let me arrange first. Can we say this is x to the power of 1 over 2, because we have 2 here, and you can take it to the under the power of this. The power of this is 1. So we can say square root of x, then this is equal to, the derivative of this one is equal to, let's say, take this 1 over 2 to the coefficient and put -1 to the power, so we can solve as a power function. So x to the power of half minus 1, it means -1 over 2. If you don't understand this, guys, you can do it by yourself. 1 over 2 minus 1. How can we do this? You can write the denominator for both and make us the same denominator, multiply by 2, and we have 2. 1 minus 2 is minus 1. So the answer is -1 over 2. Okay? So then, let me write this 1 over 2 again. And x to the power of -1 over 2, right, you have to take this to the denominator in order to remove this minus. So let's say we have same fraction. It's okay to connect with the 1 over 2, x to the power of 1 over 2. And then we have to change this x to the power of 1 over 2, clean this 2, and take it to square root. Okay? Let's say square root of 2, because at the beginning we change it square root to power 1 over 2. Then here we can change 1 over 2 to again square root of x. So square root of x, derivative of square root of x is equal to 1 over 2 square root of x. But we have a simple way, not need to take this way, but you have to know this way too. This is academic way, and you have to use for some examples. Okay. Here, the most easiest way is this. Look, this is, we have power 2, so of course we have to write 2 here. Square root of 2, we have to write here 2. What do we have in the inside the square root x? Write x. Okay, here I will tell you one way. Write itself, write it as derivative inside the square root. We can say itself. This is self, itself. Okay, and in the up write its derivative. Okay, it is derivative. We mean by the derivative of inside the square root. What's the derivative of x is 1. Look, the answer is 1 over 2 square root of x. We can finish this by 2 words. One of them is self, the other one is derivative. 1 over 2 square root of itself, and it is derivative. Now let's jump on those 2 integrals. This is derivative, you know derivative, I repeat it again, and let's go to integrals. Here we have -6 over x to the power of 4. Okay? Again, there are 2 ways. One of them is take the x to the power of 4 to the upward. It becomes x to the power of -4, and then take this -4 or plus this -4 by 1, add them, and then divide by the answer of this. So -6 x to the power of -3 over -3. Then simplify this, it becomes 2. Then take this x to the power of 3 to the denominator, it becomes x to the power of 3. Look, we have same thing here, but don't forget to write c, because maybe here we have +2. Maybe we have 2 over x to the power of 3. And let me show you the easiest way. Write down this again, and then subtract this by -1. Yes, I know this is integral, we have to add by +1, by 1, but here in the denominator the +1 becomes -1 in the powers, so we can say -1, and then the answer of this power, don't multiply with the 6, multiply with the number in front of x, so it becomes 3. 3 multiply, of course, by -3 by 1, it becomes -3x to the power of 3 over -6. Then minus and minus cancel, 6 divided by 3 is 2, so 2 over x to the power of 3. Right, sorry. Let me repeat again. Write down this. Instead of +1, write -1 for the power. What's the answer? The answer is 3. So then this 3 multiplied by 1 in front of x, but in negative. So -3 multiply 1 is -3, and then take this. If one student asks me, where did you get this minus? This is a rule. You can say, this is a rule I will use always if the x is in the bottom. Okay? Now let's jump on this last radical function. If we have 1 over square root of x, how can we find the derivative of this? 1 over 2 square root of x. Okay? So here we have again two ways. One of them is academic, and let's use only the academic way, or we can use this way too. Okay? We can say 1 over 2 square root of x to the power of 1 over 2. Okay? And then take this x to the power of 1 over 2 to the upward, it becomes x to the power of -1 over 2. 1 x to the power of -1 over 2, I can cancel this one too. Then I can plus 1. And the answer of this, I'll put it in the bottom. Then this is equal to what? -1 over 2 plus 1 minus 1 over 2 plus 1. It becomes what? The denominator is 1, and multiply by 2, it becomes 2 over 2. Then -1 plus 2 is 1. 1 over 2 is the answer. Or you can say half plus 1, it means half. So the answer is x 1 over 2, we have 2 here, over, I have to write this 1 over 2 in the bottom, again, 2 and 2 cancel, so the answer is x to the power of 1 over 2, and I can change this to square root. Again, how? Take this 2 to the square root of 2, and x to the power of 1, it's not need to write 1, and we have same thing here. But don't forget to write plus c also for here. Okay? You can use any way that you want, guys. You can use the easy way for this one too. It's up to you, guys. But don't forget, in integrals, just pay attention. If you can write by powers, by a single power, so you can solve like this. Just, for example, if we have 3, if we have 3, just add 3 by plus 1, and that's it. It becomes 4, and 4 right in the bottom. That's it. Okay, but maybe there is a little complicate here. Why? Because instead of plus 1, you have to minus 1. Why? Because the x is in the bottom. That's why. And now let's go to e power of x, ln x, and the others, sine, cosine, and tan. Now let's talk about 2 more functions. One of them, f of x is equal to e to the power of x, an exponential function with the base e, and the other one is f of x is equal to ln x. How can we find the derivative and also integral of ln? Okay, but we said we will study integral by the rules of derivative. Okay, so let's remember what's the derivative of ex. Do you remember, guys? derivative of e to the power of x is equal to same thing, e to the power of x. But don't forget that when we say the derivative of e to the power of x is equal to same, we have to take the derivative of the power and put it in the coefficient. What is the derivative of x? Is 1, so put 1 here. If you don't write here, it's okay. You can just write 1. Okay. But if we have a function like this, this is a complement function, which is it's so complicated, and there is e to the power another function. So how can I find the derivative of this function, e to the power of this? Just write same thing with its derivative. Don't forget those two words. It is itself, we can say itself with its derivative. Self with derivative. Look here, we wrote itself with power's derivative. Okay, here write e to the power of itself 2x to the power of 3, and it is derivative here at the coefficient derivative of power, we mean 2x to the power of 3. The derivative, it becomes 6x to the power of 2. Now let's talk about, guys, if we have not those two functions in the integral. Okay, I'm not talking about this. Let's say e to the power of x, same thing, and let's say e to the power of 2x to the power of 3. Okay, 2x to the power of 3. What should we do? Here we have same two words. Itself, it is derivative. Okay, not it is integral, it is derivative, don't forget. Same thing as we had in integrals, in derivatives. Okay, I am Mr. Circuit, I am using those two words. Okay, I made those two words to make all the rules easy. Okay, so this is equal to what? Itself, e to the power of itself, x, and it is derivative, but not here, not in the coefficient, this time under the function, under the e, or in the denominator. So what's the derivative of x? Is 1. So you can say again e to the power of x. So integral of this is equal to again this. Let's take the integral of this function, which is, we call this a component function. So this is equal to e to the power of, same thing, we haven't to change anything here, same thing, itself. Look, we have to write here self, we have to write here derivative. Write this, same thing, itself, 2x to the power of 3, and write it is derivative here. The derivative of this is 6x to the power of 2. If I want to take the integral of this, it becomes this one also. How? Look, I want to take the integral of this because this is, I know this is came from a derivative of something, so I can say the derivative is here, so this is equal to e to the power of same thing over the derivative of this is equal to 6x to the power of 2, and we have 6x to the power of 2 here. Again, cancel, it will be same thing here. Okay, now let's jump on the second function, is ln x. When we have the natural logarithm of x, ln x, we mean, how can we take the derivative? That's easy. We can say, how can we take the derivative of this? Itself in the denominator, okay, and it is derivative at the top. How? Write this x, this number written with the ln itself, and it is derivative of this is 1, so it's 1 over x. That's so easy. Now let's use this rule, those two words, in this function. This is equal to itself again over it is derivative. So itself is what? We have to write again x to the power of 3, we have 2x to the power of 3, all of them without ln, of course, this one, and it is derivative is 6x to the power of 2. Okay, so then we can take simplify more. 6 divided by 2 is 3. We can say this is equal to 3 x squared, and x to the power of 3 3 minus 2 is equal to x to the power of 1. So it becomes 3 over x. Now guys, you understand this is derivative. How can we solve for integral? Look guys, if we have 1 over x, pay attention guys, if we have division or multiplication, you can solve now. We have to take more sections and rules, then we will do it by the UDV rule, okay? So 1 over x, how can we find this? We can say this came from the derivative of which function? Look, this is the denominator, and the derivative of this we have up. So this is same itself, this is self, and this is derivative. So the derivative of the denominator is in the up. So this is the ln of x. This came from ln of x. But here we have to put an absolute value for this x. Why? Because x must be greater than 0. Okay, x must be positive, guys. Okay. How about another function that we have? For example, let's say here we have 6x to the power of 2, and here we have 2x to the power of 3. How can I know what is the integral of this? Okay, can we say what is the derivative of the denominator is equal to 2x cubed is equal to 6x squared. And do we have 6x squared at the top? Yes. So the derivative in the up and itself is in the denominator. So we can say this is equal to ln what? Ln the denominator, ln of this, 2x cubed in an absolute value. Be careful for integral, you have to put in the absolute value. Guys, let me give you an example. Can you tell me how can we solve this? What is the example? Let me clean this and tell you what, let's say, cosine over sine. Of course, x dx is equal to what? What's the integral of this? Can you tell me what is the derivative of sine? The derivative of sine is cosine. That's it. So not need to do as a fraction or anything. This is the integral of cosine over sine. It becomes ln. Okay, natural logarithm. So it becomes ln of the denominator, sine x. Can you pay attention? Here we have itself, and here we have the derivative of this. So this is the integral, the ln of sine x in an absolute value, of course. Okay, after this we will go to sine, cosine, tan. But be careful on tan. Don't make mistake. It's a tricky rule. In this video, I want to also talk about sine, cosine, and tan. Integral of those three functions. Okay, which is we call trigonometric functions. If you studied at derivative, the integral will be so easy. Now let's review a derivative, then we can learn integral very easy. We have three functions: sine x, cosine x, tan x. But before this, before starting to the derivative of those, we have to know what is the derivative of sine or cosine or tan. Here is an idea. Please use this idea. It will be so easy and you can be sure 100% when you think about this. Do you know this is x, this is minus x, and this is y, and this is minus y? But we change it to cosine minus cosine, sine and minus sine. Okay, what is this angle when the marker is on the ground? Let's say this is ground, this is 0. The angle is 0. Then the angle is increased to 20, 30, 60 till 90. So this is 90. So you increase 0 to 90 and 90 to 180 and then to this. But if I go to in the clockwise direction, this is 90 and then this is 60 and this is 0. So in this way I will decrease. In this way I will increase. Till now, do you know that derivative, it means the decreasing function, or not exactly decreasing function. You want to reduce the function. For example, if you have x to the power of 4, when you take the derivative, it becomes x to the power of 3. And then when you take another derivative, it becomes x to the power of 2. So this is reducing. But integral, it's the opposite of derivative. When you have x to the power of 4, it becomes x to the power of 5. So the power will increase. So in here, we can guess like this about the angles. This is sine. In this way, you are decreasing. In this way, you are increasing. Okay? So this way, it means derivative. And in this way, it is integral. So sine, derivative of sine is cosine. Do you get it? Derivative of cosine is minus sine. This is so easy. Let's go to integral. What's integral of sine? Integral of sine is, we have to go into this way because it means this is 90 becomes 180 and integral means increasing. So this is becomes integral of sine is minus cosine. What's integral of cosine? Integral of cosine, this is angle 0 and increase, it becomes sine. If you use this idea for some times and repeating for yourself 100%, you can find any derivative of integral without making mistake and without something that you are not sure and you're thinking, am I sure or not? If you're not sure, you can just come back to that idea and you'll be sure 100%. What's the derivative of sine x minus cos? When you say those, am I wrong or right when I say derivative of sine is cosine or minus sine? You're making a mistake. You know that the sine is, let's say sine, the sine is at the top. The derivative is cosine and the integral of sine is minus cosine. When you do this, you'll be sure. Now, let's go to the examples. What is the derivative of sine? Cosine. But don't forget the two words, same and it is derivative. It is angle, same, and derivative here. Okay, we have to write it is derivative here. Itself, I mean. Itself, and it is derivative. We have to put the angle here, itself, and it is derivative here. What's the derivative of x is 1, so you can write 1, or if you don't write, it's okay. So you can write 1 here. Now let's go to this example. F of x is equal to sine 2x to the power of 3. So what's the derivative of sine? Let's talk only about sine. Sine is cosine, so it's easy. Cosine what? We can say cosine itself and it is derivative here in the beginning. Okay, so we have to write this itself 2x cubed, and the derivative of this is 6x squared is right down here. Let's go to the number 9 and we will talk about the integrals. Okay, cosine x, this is cosine x. Okay, so what is the derivative of cosine? Derivative in this way, so it is minus sine x. So we have to write this down, the angle itself, and it is derivative here. What's the derivative of x? Is 1. You can write or not, it's up to you. Let's go to a hard question like this. Cosine 2x to the power of 3. We know that cosine is equal to minus sine. So we have to write minus sine itself, the angle itself, 2x to the power of 3. And you have to bring the derivative of this to the front of the sign, but don't forget the minus will be in the beginning, so it becomes 6x squared. So minus 6x squared sine 2x cubed is the derivative of this. Don't forget, this will be hard if you use another idea. F of x is equal to tan x. You know that, guys. There are two ways. You can change this to sine x over cosine x, and by using the definition of the quotient rule, you can solve this. It becomes 1 over, we can say 1 plus tan square x, or we can say 1 over cosine square x. Those are all same. And if we have a function like this, tan 2x to the power of 3, you can do it yourself, and I hope you can do that, and it will not be hard. Instead of each one, you can write 6x squared, cosine squared, and 6x squared. Okay, now let's jump on the integrals, guys. If we have cosine x, let's say cosine x. Start from cosine x. Cosine x. Guys, now let's solve those examples for integrals. Cosine, integral of cosine x dx. What is that integral of cosine? Is sine. So write sine x. But don't forget the two words, self and its derivative. We have to write itself, the angle itself, and it is derivative under the sine. Don't forget, in integral we have to write under the sine. It becomes sine x over 1 or just sine x. How about this one, guys? Or let's say we don't have this. Let's say we have only this, same as the derivative. It's up to you. Cosine, the integral of this, it becomes cosine. It becomes, we know that it becomes sine itself. We have to write 2x cubed over the derivative of this. Look, this is itself, and this is the derivative. Okay, so this is the derivative of this. So its derivative is 6x squared. Now let's go to sine x, and this sine, the integral of sine is what? Minus cosine. Minus cosine itself. The angle is itself, and its derivative is 1. How about this one? Or let's say we don't have this. If we have this, it becomes same as the cosine 2x cubed. Okay, now what's the integral of, let's say, sine 2x to the power of 3? It is equal to what? So we can say sine is minus cosine itself. What's itself is 2x cubed. And what's the derivative of this? Put it in the coefficient. It is 6x squared. Now let's jump on the last one. What is the integral of 1 plus tan square x? We can solve tan square x. We can find the integral of tan square x. Yeah, we can find the integral of 1, but tan square x, we can. So if you see tan square or sine square or cosine square, you can find the integral by thinking about it is derivative. Do you know which derivative of which function is equal to this? We have here tan x is the derivative is equal to 1 plus tan square x. So we can say the antiderivative or integral is equal to, again, tan x. So the answer is so easy, it is equal to tan x. Even if they ask you what is the integral of 1 over cosine square x, it's again is equal to tan x. Guys, now I want to give you homework. If you want to solve something that hard, sine x over cosine x dx. Can you tell me how can we find the integral of this? Sine x over cosine x, but don't forget we said that we can solve the rule of quotient or division rule, okay? This is a quotient rule, but we can solve. Can you think about the integral of this? Can you the derivative of which function is it becomes sine over cosine, even if we have a negative in the front of sine x and if we don't have the negative in the front of sine x. Can you think about this? In the next video I'll explain this. I hope you find the solution. Guys, thanks for watching my video. Don't forget to subscribe the channel. Bye.